It's time for Maths with Mr. Thomas.
Let's go! Chapter 11, lesson number 10, the intersection of planes. So let's look first of all at these two planes. You can see clearly that they intersect. And whenever you get two non-parallel planes, they will always intersect in a straight line, which you can see here. That is the line of intersection. You can find the equation of that line, and it can be done by writing the plane equations as simultaneous equations and then solving using elimination. However, because you're wanting to write the equation of the line, so you need your x, your y, and your z, so just really you've got three unknowns, that can't be solved with only two equations. If you had three equations with three unknowns, you could solve them. Four equations with four unknowns, you could solve them. But two equations you can't solve for three unknowns. So that will be undetermined. So the way it is done is you have to introduce a fourth parameter. Bum, bum, bum. And a lot of the time this will be done by expressing z equal to t. If z equals t, well, you can then express x and y in terms of t, and you can come up with your parametric equations. Let's look at some examples. So example 1, the equations of two planes are x take away 4y plus 2z equals 1 and x take away y take away z equals -5. By putting z equal to t, obtain parametric equations of the line of intersection of the planes. So we've got two planes, let's call them pi1 and pi2. Taking pi1 first of all, this is the equation, x take away 4y plus 2z equals 1. But first we are told to put z equal to t. So if you put z equal to t, well, all you're really doing is you're replacing z with t. So you'd have x take away 4y plus 2t equals 1. And really what you want to do is you want to have your simultaneous equations. And for simultaneous equations, you really want on one side of the equal sign your x and your y, and then the other side you're wanting anything else. So subtract 2t from both sides. That will give us x take away 4y equals 1 take away 2t. So that there will be our first of the simultaneous equations. With plane pi2, again, we're wanting to replace z with t. So instead of x take away y take away z, we'd have x take away y take away t equals -5. Again, you're really wanting x and y on one side of the equal sign and anything else on the other. So add t to both sides, and that would give you x take away y equals -5 plus t. And that is your second equation. Because we now have two equations, we can solve them really using the method that you learned in National 5, your simultaneous equations. And you can express x and y both in terms of the parameter t if you do that. So, over the page, we've got the x take away y equals -5 plus t, and we've got the x take away 4y equals 1 take away 2t. Hopefully you can see that you've got 1x and 1x, so if you subtract the equations, I'm going to have equation 2 minus equation 1. Doing that will give, well, -y take away -4y will become -y plus 4y, which gives me 3y. The x's obviously cancel out, x take away x, I'd have 0x. You'd have -5 take away 1 is -6, and t take away -2t would give us 3t. Divide both sides by 3, and it means y would equal, perfect, -2 plus t. Woo! So we've expressed y in terms of t. We now need to express x in terms of t as well. So how do we do that? Well, we just want to substitute this value of y and our value of z into one of the equations. Doesn't matter which one you sub them into, I'm just going to sub them into this equation, when we had the x take away y equals -5 plus t. So for that, you can replace the y. I'm just adding y to both sides first of all. So I've got x equals, it's the -5 plus t plus y, and then replacing the y with the -2 plus t. That will give me the -5 plus t plus, and then replace y, so it becomes the -2 add t. From there, simplify that, so I've got -5 take away 2, which is a -7, and then the t add t, which is 2t. Therefore, we've got y in terms of t, we've got x in terms of t, and we had z equal to t as well. So you can say that the parametric equations of the line of intersection will be x equals 2t take away 7. If you just rearrange that, you'd have y equals the t take away 2, if you rearrange that one, and your z was equal to t. So that would be your answer. Woo! Let's move on then. Let's say we have 3 non-parallel planes in 3D space. If we have that, then you have 3 different options. They may intersect at a point. So you can see here these 3 planes, the red one, the blue one, and the black one, well, they're just intersecting at that one point. That's where they intersect. You could also have them intersecting once again in a line. So you may have something like this, and you can clearly see that they're intersecting in that line there. Or what you may have is you may have 2 of them intersecting in a line, but it doesn't intersect with that other one. So they may not all intersect at the same line or point. So you could have something like this. So let's go through this and let's look at an example of each of these. If you've got 3 planes, we can find out the point of intersection, or we could find out the line of intersection, or we may find that they don't all intersect at the same point or line. So, first off, Gaussian elimination can be used to find the point or line of intersection of 3 planes. So with example 2, find the point of intersection between the 3 planes. Let's call them plane 1, plane 2, and plane 3. Woo! What an imagination. So, plane 1, we've got x take away 2y take away z equals 3. Plane 2 is 2x add y take away z equals -1. And plane 3 is -x add y add 2z equals 2. It says here, Gaussian elimination can be used to find the point or line of intersection of 3 planes. So, we need to set this up and solve using Gaussian elimination. So that is when you take the coefficients of x, y, and z and this number that they would all be equal to, and you're wanting to write it out just in matrix form. So we've got 1x, -2y, -1z, so we've got 1, -2, -1, and that would equal 3. On the next one, plane 2, we've got 2, 1, -1, and -1, so we can write that out. That would be row 2. And with plane 3, we've got -1x, 1y, 2z, and that's equal to 2. So we've got -1, 1, 2, and 2. You know, for Gaussian elimination, you are wanting to start off by setting these values equal to 0 using a combination of row 2 and row 1, or row 3 and row 1. So for row 2, how do we get this to 0? Well, we've got 2, and if we double row 1 and take it away, well, that would give us 0. So we can say that row 2 would go to row 2 take away 2, row 1. With row 3, we've got -1. How do we make 0 using 1? Well, we could just add it on, so we can say that row 3 would go to row 3 add row 1. So doing that, the top row 1, will just stay as it is. It is not changing. So that will stay as 1, -2, -1, and 3. Row 2, what will that become? Well, we're taking row 2 and we're taking away double row 1. So it'll be 2 take away 2, which gives us 0. We'd have 1 take away -4, which will give us 5. We'd have -1 take away -2 if we double that, and that will give us 1. And we'd have -1 take away 6 if we double that, so that will give us -7. With row 3, what does row 3 become? Well, that's row 3 add row 1, so it's -1 add 1, which will give us the 0, which is what we want. We'd have 1 add -2, which is -1. We'd have 2 add -1, which is 1. And we'd have 2 add 3, which is 5. Woo! Remember, Gaussian elimination, you are wanting to get your zeros here, which we have. We do indeed. And you're also wanting to get a 0 here as well. How do we do that though? We can use row 3 and row 2. So you would have to use just row 3 and row 2. Remember, don't use row 1, because if you use row 1, well, this value will change from 0 to something else. So using row 2 and row 3, what do we do? Well, we can say, this is just what we had in the last page, we wanted to set this equal to 0. So we can say if we multiply row 3 by 5, that will give us -5. And if we add on row 2, well, that'd be -5 add 5, which would give us the desired 0. So keep row 1 just as it is. Keep row 2 just as it is. And with row 3, it's 5 times row 3 add row 2. So 5 times 0 add on 0 will give us 0. We'd have 5 times -1, so -5 add on 5, which will give us 0. We'd have 5 times 1 add on 1, which gives us 6. And we'd have 5 times 5, which is 25, add -7, which gives us 18. Once we have this triangle of zeros, we can then solve. So, starting with the bottom row, starting with row 3, just remember the 6 is the coefficient of z, so we can say that 6z equals 18. And if 6z equals 18, well, we know then, if we divide both sides by 6, that z would equal 3. We can then go up a row, we can go to row 2, hello, and we can sub the value of z in for here. So we can say then that 5y plus 1z equals -7, and replacing z with 3, because we know z is 3, we can say that 5y add 3 is -7. Subtract 3 from both sides, so 5y is -10, divide both sides by 5, and y would equal -2. Woo! So we know y and we know z, and we can go up to row 1 to find out now what x would be. So with row 1, we've got 1x, take away 2y, take away 1z equals 3. And if we replace y and z with their values, what will that give us? Well, that works out to be x. -2 times -2 will give us +4. We'll replace z with 3, so it becomes take away 3. That would equal 3. It means then that that'll be x add 1 equals 3. So we know that x would equal 2. Woo! So we can finish off saying that x equals 2, y equals -2, and z equals 3. And in the question we were asked to find the point of intersection for the 3 planes. So we know then that the point of intersection, so the 2, the -2, and the 3, so we can say then that 2, -2, 3 will be the point of intersection. Woo! Example 3, find the equation of the line of intersection of the planes. X plus y take away z equals 0, 2x take away y plus 4z equals -3, and x plus 3y take away 5z equals 2. Once again, we are wanting to set this up using our Gaussian elimination. So, take the coefficients of x, y, and z and take this number just on the right-hand side. So, row 1 will become 1x, 1y, -1z, so 1, 1, -1, and that equals 0. That's row 1. Do the same for row 2. Take the coefficients of x, y, and z, so we'd have 2, -1, and 4, and that would equal the -3. And for row 3, we'd have 1, 3, -5, and 2. Remember, with your Gaussian elimination, once again, just like the last example, we want to set these values equal to 0. So to do that, use row 1. So with row 2, what would happen to row 2? Well, you'd have 2 take away, and if we double row 1, that would give us 0. So we can have row 2 take away 2, row 1. With row 3, well, we've got 1 here and 1 here, so how do we make 0? Well, we just subtract. So we can say that row 3 would go to row 3 take away row 1. So row 1 is staying just as it is. We'd have the 1, the -1, and the 0. Row 2 would go to row 2 take away 2, row 1. So if you do that, you would have 2 take away 2, which is 0. You'd have -1 take away 2, which is -3. You'd have 4 take away -2, which gives us a 6. And -3 take away 0, which is just -3. Row 3 is row 3 take away row 1. So row 3 take away row 1, it's 1 take away 1, which is the 0. 3 take away 1, which is the 2. -5 take away -1, which gives us -4. And 2 take away 0, which is 2. Again, we're wanting to get this triangle of zeros. So we've got the 2 zeros here at the start. Woohoo! But we also want to make this equal to 0 using row 2 and row 3. How do we do that? Well, we can say that if we multiply this by 3, that will give us 6. And then if we add on 2 lots of row 2, well, that would be us adding on -6. So 6, take away 6, would give us the 0. So we can say that row 3 goes to 3 row 3. So we'll multiply that by 3, and then we would add on 2 lots of row 2. If we do that just over the page, this is just what we had in the last page. This is what we're wanting to make 0. And doing that, so the 3 row 3 and 2 row 2 will give us, well, this entry here will work out to be 0. If we multiply this by 3 and then add on 2 lots of the 6, that will also give us 0. And then multiply this by 3, so 2 times 3 is 6. Add on 2 lots of the -3, that will give us 0. So the bottom row just becomes 0, 0, 0, and that would equal 0. So in other words, 0x add 0y add 0z equals 0. But never fear, go up to the next line, go up to row 2. So with row 2, we can say that the negative 3, that's the coefficient of y, so negative 3y plus 6, that's the coefficient of z, would equal negative 3. We can rearrange this and we can solve to get y. We can say, if we divide everything by 3, that negative y plus 2z equals negative 1, and we can rearrange that. If we add y to both sides and then add 1 to both sides, we'd have y equals 2z plus 1. So y is going to be written in terms of z. Going up to row 1, well, we've got 1x, add 1y, take away 1z equals 0. So we can then replace the y with the 2z plus 1. So doing that, we've got x add 2z add 1, take away z equals 0. If you simplify that, that will give you x add z, add on 1 equals 0. And again, you could write x just in terms of z. So you've got both x and y in terms of z. But remember, you're wanting the equation of the line. So for the equation of the line, you're really wanting your parametric equations. So we need to introduce a fourth parameter. And the parameter here, most of the time, it's just going to be z equals t. So you can do that here. If we let z equals t, this will give us the parametric equations. Well, you would say z equals t, but it means y, instead of y equaling 2z plus 1, but we replace z with t, so you'd have y equals 2t, add 1. With x, instead of negative z, take away 1, replace z with t, so you'd have x equals negative t, take away 1. This means that you will have your x equals negative t, take away 1, y equals 2t plus 1, and z equals t. That there will be the parametric equations. If we wanted to go on further and write the equation of the line in symmetric form, well, you know, in symmetric form, all you've got to do is to rearrange it so you get t equals, find out what t is, and then you'll get your 3 fractions. So to get t in its own, we'd have to add 1 to both sides. So we'd have x add 1, and then you would divide by negative 1. So you'd have x add 1 over negative 1. To get t in its own here, you'd subtract 1 from both sides, so y take away 1, and then divide by 2. So y take away 1 over 2. And then here, you've got z equals t, so really it's just going to be z. We're adding or subtracting nothing, and then we're dividing just by 1. So we're writing it out with 3 fractions, and that would be the equation of the line in symmetric form. Woo! Example 4, show that the following planes do not intersect. So once again, you've got 3 planes. Plane 1, x add y add z equals 2. Plane 2, 2x take away 2y plus z equals 5. And plane 3, 3x take away y plus 2z equals negative 1. Start off with your Gaussian elimination. So take the coefficients of x, y, z and take this number on the right hand side. So row 1 will be 1, 1, 1 and 2. Row 2 will be 2, negative 2, 1 and 5. And row 3 will be 3, negative 1, 2 and negative 1. We are wanting to solve these using Gaussian elimination, so we want to make these values 0 using row 1. So we can say that row 2 will go to, and that will be row 2 take away 2 lots of row 1, because that will give us 2 take away 2, which gives us 0, which is what we want. With row 3, well, to get the 3 to 0, we'd have to triple row 1 and then subtract it. So row 3 will go to row 3, take away 3 lots of row 1. Doing that, row 1 will stay as it is with 1, 1, 1, 2. Row 2 take away 2, row 1, so that will give us 2 take away 2, which is 0. You'd have negative 2 take away 2, which is negative 4. 1 take away 2, which is negative 1, and 5 take away 4, which is 1. Row 3 is row 3 take away 3, row 1. So doing that, you will have 3 take away 3, which is 0. You'd have negative 1 take away 3 times 1 is 3, so negative 1 take away 3 is negative 4. 2 take away 3 is negative 1, and negative 1 take away, that's taken away 6 if you triple that, so you'd have negative 7. So we've got the 0 here and the 0 here. Well done. But we now want to make this entry 0 as well, just using row 2 and row 3. So how do you go about doing that? Well, you can say that row 3 take away row 2, well, that would be negative 4 take away negative 4. And if you subtract a negative, it means you add, so you'd have negative 4 add 4, which would give you the 0. So row 3 would go to row 3 take away row 2. So doing that just over the page, this is what we had. We are taking row 3 And from there, we are subtracting row 2. So row 1 and row 2 are staying just as they are. They are not changing. But the other row, row 3, that would be 0 take away 0. You'd have negative 4 take away negative 4, which gives you 0. Negative 1 take away negative 1 would give you 0. And negative 7 take away 1 is negative 8. Bum, bum, bum. However, if you think about this, think about the bottom row. With this bottom row, the zeros are the coefficients of x, y, and z. So you would have 0x at 0y at 0z equals negative 8. So in other words, you would have 0 equals negative 8. Boom, boom, boom. This is impossible. It makes no sense. And because of this, what it means in relation to the planes is it means they do not intersect. Woo! And that answers your question. Try these questions looking at the intersection of planes. You're on page 48 on the Unit 3 workbook. If you still need the workbook, send me an email. Best of luck. Have fun. And if you need to practice some Gaussian elimination, go back to those questions just in the start of the Unit 3 workbook. Woo! Enjoy. See ya. Howdy.